Hey folks, Jen Foxbot here, and welcome back to Math Mondays. Woo! A lovely person submitted a math problem, so I'm really excited because I get to tackle a real world problem for y'all today. Or better yet, we get to tackle it together. And actually, this problem is super related to the one that we did last week, where we calculated how close a main memory module needed to be to a CPU or computer or central processing unit in a computer. And we found that it was less than a meter, which is good. But that's actually pretty big. Also, probably because the computers back when that textbook was written were probably way bigger than the computers that fit in our pockets. I looked for my pocket and then realized that my smartphone is in front of me filming, so not in my pocket, but it does fit in my pocket. Anyway, so welcome back. In this episode, we'll tackle a 3D printing problem. So this gentleman asked at what speed or what percentage increase in speed would he need to start a second print if he had started it a certain time after the first print. And so I asked for the 3D printer type, the speed of the printer, and some other specs, and then realized as I was sitting down this morning, like, oh, actually, we can do this abstractly. We don't actually need any numbers to solve this problem, or at least to get an equation that you can use to then plug in numbers and then determine the percentage increase in speed for a given scenario. Which makes it a little bit easier because then depending on how long it takes you to start the second print, you can find the appropriate percentage speed increase. So hopefully this helps folks that are doing 3D printing. Yeah, all right, so let's get started. Woo! So we will need just one equation, the same equation that we used last week, which is speed or velocity. And so that is v equals x over t. And our smart brains remember that this is actually the change in x and the change in t. X is distance, t is time. But we like to be lazy, so that's okay. So what I'm going to do is we're going to set up a relationship, and we're going to solve for the speed of the second printer. So what I'm going to do is I'm going to use a thing called subscripts so that I can keep track of all of my different variables. So we're going to call this the speed of printer 1. This is going to be basically x is how much the printer is moving. So technically our printer is moving in 3 dimensions, but since we want to be lazy and keep it simple, I'm just going to assume it's 1 dimension. Effectively, the math is the same. You could just repeat this for all 3 dimensions and you should get the same result. So we'll call this x1, how much the printer is moving in print 1. And we'll call this T1, which is the time it takes the first printer to finish a print. Okay, now for the second equation. Well, it's the same equation, v equals x over t, but in this case our subscripts change because we're talking about the second printer. So v2 is the speed of the second printer, x2 is how much the second printer is moving, and t2 is the time that it takes the second printer to finish. So, first, what we can knock out, assuming we're doing the exact same print, that is crucial, then we can say that x1 equals x2. Boom, done. And I can erase my subscripts. So that simplifies things right off the bat. The second thing that we know is that although v1 and v2 are different, t1 and t2 are also different, but t1 and t2 are related. Because we start this print, and then a certain amount of time later, we start this print. So the first print will be running for more time than the second print. Well, how much more time? It depends on how long it takes you to get your act together and start the second print. Since we want to do this for an arbitrary amount of time, 20 minutes, 30 minutes, 45, maybe you leave the house and come back because you needed a sandwich or something. It's very important. Maybe it takes you an hour and a half. We don't really care at this point. What you want to know is when you actually go to start the print. So what I'm going to do is I'm going to say T1 equals T2 plus some arbitrary amount of time, which I'm going to call delta T, which is change in time. So T2 is this same T2, and delta T is basically the difference in time, or the amount of time it takes us to start the second print. So say I start the first print and I go and grab a cup of coffee and I come back 10 minutes later and then I start the second print. That means that T1 is going to be T2. It's going to take the same amount of time. That's our goal. Plus 10 minutes. Cool. All right. So let me know if you need more clarification on that. I'll leave that there for now. But now that we have this information, we can rewrite these equations. So V1 equals X over T1, which is T2 plus delta T. And, little and sign, V2, to separate those, equals X over T2. Okay, hopefully y'all can read that. Our goal in solving for V2, because that's what we're interested in, we need to know how much faster we need to run the second printer. Our goal in solving for V2 is to basically get rid of as many different variables as possible to simplify our problem. So what we can do now is we see that we have X in both equations, so we can use substitution. Huzzah! So X, another way to write X using this first equation is V1 times T2 plus delta T. And then if we do that, we can write V2 equals, oops, I guess we don't need that, V1, we substitute X, T2 plus delta T over T2. Boom! There you go. That is our equation. So this is what we would need to figure out the percentage increase in the speed to get the two same prints to end at the same time. What does this look like in practice? Let's use some specific examples so that we can actually understand how this works. Okay, so let's assume that our print takes an hour. If we were to start them at the same time at the flat speed of the printer, or I guess like the default speed of the printer, that print would take an hour, which would be 3,600 seconds. So let's say that T2 equals 3,600 seconds. Then let's say we start the first print and it takes us 20, or let's go 10. I like 10 because it's a little easier to do mental math. Let's say it takes us 10 minutes to get our ish together and start the second print. So then delta T equals 600 seconds, because 10 minutes times 60 seconds is 600 seconds. Then V2 equals V1 times T2 plus delta T. 3,600 plus 600 is 4,200 seconds, divided by 3,600 seconds. The units cancel, which is good, and then because I'm lazy and I don't want to do mental math, you just cross out the zeros, but whatever. Also, you can use a calculator. So if I do 4,200 divided by 3,600, I get, boom! There is our result. Da-na-na-na-na-na-na-na-na. I love math because it helps us solve problems like this. Okay. So V2 equals 1.1. Whoopsies. I got ahead of myself. Oh my gosh. 1.167 times V1. Okay. So hopefully we can see that. Huh. Okay. Yes. So basically, V2 needs to be about 17% faster than V1. Or said another way, you would increase V2 to be 117% of the default speed. Boom! QED, or as my professors used to do, little square. Yeah. Oh, there we go. So yeah, you can use this equation for any amount of time that your print speed is going to take, and for any amount of time that it takes you to set up the second print. So V2 equals V1 times parentheses T2 plus delta T divided by T2. use that and make your life easier. And like I said last week, I will be doing these as a weekly series on different math problems, and please send me your math questions, whether it's a problem that you're running to in class, or if it's a math issue that you've just been like, I don't understand this thing, even though I've taken 1,000 classes. What are eigenvalues? Let me know. We're here to do this together, or I'm here, and hopefully you're here to do this with me as well. So yeah, I encourage you to run through the math yourself, check my work, please, and let me know if you have any questions. All right, thanks for watching, and see you next time. Bye!